This aspect of our project was coming up with a lot of the terrains and areas we'd be navigating and playing in. And I'd like for Josh and Paul to come up and describe what they did with it.
We use Earth Sculptor to create the height maps that are used in the game. We started out with drawing what we basically wanted our levels to look like on paper, and then using Earth Sculptor we created the height map, which is shown here. This is an example of one of the height maps used in the game.
Yeah, so when we first started off, we decided that, okay, let's just draw all the maps that we might need on paper, and then we went inside our Earth Sculptor and we started making these height maps, these levels that our game is going to use. Here is an example of Earth Sculptor and what it would look like. But as the previous image shown, all we needed was the height map, the black and white image, and what the white image shows is the outline. As you see, the outline is the elevated walls inside the game.
We used auditorium to put in the terrain's color and different entities that are found in the game, such as spawners and the towns.
Here's an example of a finished map in auditorium, fully textured, and it has been filled with Hydrax, a water rendering program. In auditorium, here's a picture of auditorium. Once we loaded in the height map, we had what we needed, so we just polished up what the level would look like. We gave it some textures, and we placed objects as our artists actually gave us throughout the level, our spawners, our buildings, our random debris. And then once we were done with that, we just saved it, exported it, and fed it to the program, which loaded it in very nicely. All very simple process.
This is an example of SkyX, Hydrax, and the main world of our game.
Thank you, guys. All right, the next aspect of our game is going to be the graphical user interface. Kevin and Michael headed that up. I'd like for them to come describe their experience with that. They used a plugin for Ogre called MyGUI to do the majority of their work.
Hello, I'm Michael Murray.
And I'm Kevin again. So together we built the GUI, or the graphical user interface. This is how a user gets to interact with the game. There are two main forms of interaction. First is the system of menus that allows you to get to gameplay, set up your character, and do any video, audio settings, things that you need. The other aspect of the GUI is giving the user real-time feedback when they're in gameplay. So you can see an example with the picture on the right. In the top left corner, there's an example showing this is your health, this is your energy level, things like that. Both of these kind of things are handled in the GUI.
All right. At the beginning of the semester, when we were doing tutorials, most of the tutorials required use of CD GUI, which we found was not really flexible, which is one of the main reasons why we went with Ogre. MyGUI. MyGUI is easily integrated inside Ogre. You can make your GUI using widgets, which is part of MyGUI. Widgets can have different types. You have your buttons, button widgets, window widgets, sliders, drop-down menus. Probably one of the most beneficial aspects to using MyGUI is the use of XML. XML is used to create the layout files, which we use to create our GUIs. What this allows us to do is to make changes to a layout, such as changing the size of a button on a window, adding buttons and windows, changing skins, adding skins, without actually having to recompile code. And yeah, as I said earlier, my GUI allows us to import skins. Most skins were made in Photoshop, imported in as PNG files.
All right, so next I'll show you just a couple examples, and while you look at those, I'm going to talk about the two main concepts we had to consider when we were designing the GUI, and those are states and layouts. So the state that the GUI is in, we decided early on that we would follow exactly with the state that the game was in. It made sense. And so at any time, the GUI can be in a state, and then we also need to know what layout it is, what you're going to see, what functionality it offers. And as he mentioned, we had these XML layout files that helped us really switch between layouts within a state so that we could provide really snappy menus and things like that without having to switch over between states. So what you're seeing here are two of the states that had just a single layout, and then an example of a multi-layout state is our menu state, where each of these are a separate layout file that all we're doing is asking the game to load a different file, and you see a completely different interface. You get a different set of options. The other thing that you can see is that we have a lot of work done on the skinning, and I'm going to let Michael talk to you about that.
Well, I already explained XML earlier and how it's useful in my GUI. So I was going to explain the general order to creating skins and implementing those into the layouts. Initially, we created drafts of the layouts of what we would want them to look like in the final state. Once we have created our drafts, we would implement a rough layout inside Olga using my GUI. As you can see here, we have this is just the very early version of the setting states or setting layouts. This is a layout in that for editing video options, deciding the screen, and this is the other one of editing the sound. Once we have rough layouts, so we can actually see and make changes to rough GUI design. We went about rescanning everything. Set skins just made in Photoshop, imported, and once we imported the skins, we need to put those in a resource file, XML, so that you can use that in my GUI, and then we have to link that to a layout file. And here you can see added background. This is kind of similar to the previous version with the selections and options. We just added a menu inside, a window inside of a window to make have a bit more depth to it.
All right, there you go. All right. The next aspects of our game is going to be our artificial intelligence. This is going to be where the user is interacting with the other objects in the game that are controlled primarily by pre-programmed actions that are handled by both Josh and Blake.
Hello everyone, my name is Blake Edler, and this guy you've met a couple times already, who's Josh.
I'm Josh.
All right, and we represent the esteemed artificial intelligence department of this project. So Josh is going to go ahead and give a talk about our state switching architecture, the finite state machines.
So from early on, we decided that we wanted to design a finite state machine for our artificial intelligence. What a finite state machine is, basically, is we give it a set of rules for the enemy to follow. Once those rules have been met, then it will react accordingly. Like one state, AI state wander, our enemy would just wander around aimlessly searching around for our player. And if it sees the player, then it goes, okay, I'm going to go to the next state, and I'm going to start chasing you. It's basically how we design our finite state machine. Here is our finite state machine. When we first start off, we start off in the wonder state, and then once the player gets in range, it switches from wonder to chase. And from there, it just chases until it either gets within range or loses sight of the enemy. If the player is in range, then it begins its attack sequence. It attacks, and if the player somehow escapes our intelligent artificial intelligence, then it begins to chase again. If the enemy dies, then it queues up to say, okay, I'm dead. But if the player gets away and the enemy loses sight, then he begins to search again. That's basically our finite state machine.
All right, so the next item up for bid is the line of sight. And anyway, the basics of the line of sight is that we establish a radius that will be our search distance. And we first check to see if a player is within that distance. And then step two is that we check within a certain angular view radius or view range, plus 80 and minus 80 from straight forward. Thank you. And then step three is once we establish that, number one, we're within our view circle, which is depicted here. We check if we are within this angle. And then step three, we shoot a racing query from the eyes of our AI object straight to the player object. And if we encounter anything along the way, such as this obstruction here, well then we can't see our player. But if in the instance of object C over here, he's within the distance, number one, he's within the eyesight of the direction that we are facing, and number three, we have a clear path to them. So that's how we model the eyesight. And for our pathfinding, this is a waypoint graph, is the way we set it up, is as we load each level, we do it based on height maps, like as they showed for the level design. And as we load these height maps, such as this one here, we're only interested in the inner region of the height map. We don't want to pathfind to the outside of the out of bounds. So the way we set it up is we generate a second image which only shades the areas we're interested in placing these nodes that we use to follow for our pathfinding. And so what we do for pathfinding is we start at one of these nodes here and say if we wanted to pathfind to this node here, it would use an A-star search algorithm to generate a path, the shortest path from this node to the other one. It just connects the dots.